Thank you for coming, and thank you for the organizer for inviting me to give this talk on Unison. So, by show of hands, who has heard of Unison? That's basically everybody. And who has programmed in Unison? A little bit less. Welcome. I hope that the interest in Unison will be a valuable addition to your knowledge. And at this conference, I've been to a few talks, and some of those talks talk about language impedance, that if you work in the back end, you have to work in a different language on the front end maybe, and you want to leverage that. And I've heard a talk about lenses, how to mitigate the changes in the model to the database or our services. And I think that Unison is a language that does this very well in the sense that they go away. So without further ado, let me introduce you to an origin story in a sense, how I get into Unison. And I was with a team at the time that was working in Kotlin, and we had a new colleague, and that colleague had a different background. So she studied mathematics, had no formal training in software development, and our company offered those people a chance to learn how to do software development and contribute software. So she was assigned to our team. She was wickedly smart, but she had no formal training. So we started out teaching her Kotlin. And she got the grasp very soon, and when she wanted to deploy the service that we were working on, she was asking, so what do we do now? And then we had to sit down and say, well, that's a bit complicated because Kotlin is compiled to Java bytecode, and that bytecode needs to run on something, and we're going to package that in a container, and that container needs to be deployed to our cluster, and that cluster needs to be configured correctly, and we do that with Argo CD. So there were all these tools and languages that she needed to learn on top of Kotlin in order to do her work properly. And I think this is a situation that is very strange because we have this language that allows us to communicate what a machine must do in a single instance, but as soon as we cross the border to a network of machines, we lose all those capabilities that we are fond of, static typing, expressing intent, and basically write YAML to hook up everything. So this is a situation that the originators of Unison saw and addressed and tried to solve with Unison as well. So who am I? My name is Daan from Berkel. I'm from the Netherlands. I work for Alliander. I used to work as a software developer. And Alliander is a utility company responsible for distributing power and gas in large parts of the Netherlands. And like every utility company, we have a challenge to have an increased energy demand that we have to distribute. And we try to do that with smart solutions. So if you're interested in these kinds of problems, come talk to me because we actually are hiring. There's a caveat. I'm not associated with the Unison computing team, the team responsible for Unison. I'm an enthusiastic member of the community, which is very nice to be a member of. But all that I say is my opinion. It doesn't reflect the opinion of Unison, I guess. Although they are very friendly, and they know that I'm doing this, and they gave the green light, so that's nice as well. So let's start with a demo. What I'm going to do is I'm going to start a Unison code manager, codebase manager. That is basically the tool to interact with Unison. Is this, first of all, readable to the people in the back? Yes and no, maybe a bit bigger. So let's do this and this. So I'll get my screwdriver and I will. Okay. So one of the non-classical things that Unison does is that it has a codebase manager, and we'll go into that more, but I want to start out with viewing a definition. And this is a Unison term, and I'm not going to go into the details yet, but what this describes is how to deploy a service to the cloud. And this is maybe strange for you if you're from the world that needs to deploy with all these CCD machines and packaging YAML and whatnot. You can run this. That's wrong. And the Wi-Fi for bidding, if it is going through, then it will actually deploy a service to the cloud that we can then address. So let's open a different window that we need to make a little bit bigger. And we can curl, for example, Lambda days. And it says, hello, new friend Lambda days. And if you access that point again, it will say, hello, old friend Lambda days. So this is a service with state, with routing and stuff, which is quite impressive. And this is all done within Unison. So this is one of the key benefits of Unison. The idea is that everything should be Unison. And that has some benefits and also some downsides, which we'll go into later. Does anybody have questions already? Great. So there's a folklore joke, you probably know it. There are only two hard problems in computer science. It's cache invalidation, naming things, and OP1 errors. And it is the naming things that's interesting, because naming is hard, everybody thinks, will agree. And one of the reasons that naming is written down here, because it's very important. If you are able to name something, you free up your mind to communicate about it. So instead of saying, I have this thing that has these characteristics, maybe you can say there's a function that allows you to succinctly express yourself and communicate with others. So that's one thing that naming is hard. And the other thing is, if you name something, you have a reference to it. And if you have a reference to the same thing with another name, you might run into alias problems. And these problems are interesting in itself, and I think Unison has an idea how to solve that. So let's look at a high overview what Unison does, other than modern day languages. So a lot of languages still use a file as the means of communicating your model and intentions. And not only that, usually it's a bunch of files, right? I haven't seen a single project in the last 10 years that only uses one file. And the thing is, these files have relationship with each other, and this is all nice, but the problem begins when one of these files is defunct or faulty, then all the dependents on that file are basically defunct as well. And it's not even these relationships of the files that we're interested in. In a sense, it's the abstract syntax tree that we want to know. What is the model that we express in those files and their relationships that we want to convey? So this abstract syntax tree is actually the bread and butter that we work with, but we tend to be stuck in those files, and we tend to have tooling on those files, which is in a sense the wrong way around, because that abstract syntax tree is the tree that we want to manipulate in a sense. And that is what Unison is doing. There are files, we're going to show that a little bit, maybe you already know, but that's not the essence of Unison. The essence is the abstract syntax tree and how it is represented in the Unison Codebase Manager. Again, the abstract syntax tree doesn't have to be monolithic, there can be references, but they tend to be abstract syntax trees as well. And then you have to think about how do you reference an abstract syntax tree, or how do you reference an evaluation of an abstract syntax tree, and how do you do that? So one of the things that you can do is, because an abstract syntax tree is just a representation of maybe a computation that is immutable, you can take a hash of the abstract syntax tree in a sense. Let's say it's a number, 37, and then what you can do is, because the abstract syntax tree that you're interested in has this hash, and that abstract syntax tree is not going to change unless you want to have another computation, you can take that reference as a name for that abstract syntax tree. And in that sense, you can use these hashes to talk about these abstract syntax trees. And this is basically what Unison does. Instead of having a bunch of files that represent a textual representation of the abstract syntax tree, you add these abstract syntax trees to your code base and have references by hashes. Is that clear? Good. So if that's clear, my talk is over. I can go and have some early lunch. No. So let's see how that pans out. So I will take a look at my notes and the time. Sure. So we're looking at the Unison Codebase Manager, and what it allows you to do is basically explore your code. So we just saw the deploy term that allows you to deploy a thing to the cloud. And you could peruse this and understand this and maybe think of what the dependencies are, but you can also ask it. And it gives you a list of the types that are used in the expression that we just saw, and also the terms. And you can get a sense of what is involved here. And what you can also do is, maybe I'm interested in the demo1 service, so we can view that. This is the actual service that's going on. I'm not going to discuss the intricacies of the language itself at this moment. If you have any experience with Haskell or other functional languages, you probably can understand the type signature, what is happening. But for now, it's enough to understand that you can use the code manager to see this code. So we just saw that there are dependencies that you can ask for. But the other way around, the relation that something is dependent on me is also questionable, discoverable. So what I can do now is ask from this term who depends on me, which is interesting. And we now see that it's the deploy function itself, and also something called demo1 deploy depend doc, which is a documentation. So the nice thing about Unison is that documentation is a first-class citizen in the language. And you can ask about it. Oh, that's one too many. And it shows you a textual representation of the documentation. But the documentation itself is a term. So if you view the documentation term, you will see a domain-specific language for expressing documentation. And it shows you that it's possible to reference demo1.service. If you stop and smell the roses, the demo1.service is an actual term, and there's a reference to that term that is discoverable. So that means that if you change the name, for example, this is a better example, if you change the service and it becomes a different thing, this reference will be noticed at because it's referencing by hash. Let me reiterate. If you change service so that the abstract syntax tree changes and becomes something else, then this reference will notice that and will be updated as well. If that doesn't blow your mind, I'm not sure what exactly, but I'll try my best to find something again. So there are things that you can do. You might have noticed, but it's gone on the screen, that you, in the service, there's a function, something called greeting. We constructed a greeting for a person, but maybe you're not sure how to find that. So what also is a capability of the Unison Codebase Manager is fuzzy finding. So there was something with greeting, and the codebase knows that it is greeting 4 that you can look at. So here is the definition of how to greet somebody in that service. Which isn't very interesting, but at least it shows you the capabilities. And you can also have a more explicit find method that shows you what are terms that have names similar to greeting. And then we see, besides the documentation that I already talked about, that there are also the tests. So let's ask the Codebase Manager to edit the tests by listing the numbers that we found here. So I'm going to reload my editor and bring this into view. And here are definitions of Unison terms that are actually tests. So again, Unison has a particular view on what software development should be, and tests are first-case citizens. And we can execute those tests, or actually we can see the results of those tests and see that they're all passed. But keen observers notice that these are cached results. So the wonderful thing of Unison, again, is that everything is an abstract syntax tree, also evaluations of that. And if you once have computed it, it will not change because the abstract syntax tree will not change. So instead of recomputing the result, you can just present the result as is. And this can be shown by creating a new test. So does anybody have a name in this room? And that they want to share with me for this purpose of this demonstration? Leo, thank you. Hello, new friend Leo. So if we call this function with the name Leo and we have visited that name 0 times, we should expect that the result is hello, new friend Leo. So if I'm going to save, what's going on? If I'm going to save this file, Unison will pick up the changes to the file and will load again these files. And what we see now, it's a bit big, so let's change that. What we can see here is that all the tests passed, which is a good thing, but some of the results are cached and others aren't. And the line 12 has a passed result, but it is not cached. So furthermore, the codebase manager that's on top of the results asks us to add this new definition to the codebase manager. So let's go on and add that. Then basically what we have done now is we've written in a file that's checked by Unison in the means necessary that we're comfortable with. This could be Visual Studio Code, this could be any editor you want. The changes will be compiled by Unison, and then that abstract syntax tree of all the references to all the R functions will be added if you add it to the code base. So now this lives in the code base. And if we run the tests again, test again, you see that all the tests are cached. Does that make sense? Is this impressive? Yeah, woo! So this is the way how you interact with Unison codebase. So for example, I just met Leo as a new friend, but I met him now. So if we... Sure. Could you repeat the question a little bit louder?
How the caching behaves if environment changes and it's not interacting.
So the question is, how does the code base changes if the environment changes? So the question I would ask is, what environment are you talking about?
Well, let's say you're testing the environment that you have a database, and you're testing directly with a connection, whatever, something external.
Sure. So the question is, what if I want to test something with the database? So Unison is a functional programming language, which is also pure in the sense that the functions that are defined are not depending on I/O or something. We'll go a little bit into how Unison addresses that, basically with abilities. So these functions don't rely on the environment or databases or I/O. If you write a function that does do database connections or stuff, basically I/O, you can only do that by having a signature that signals that there is an ability needed to express that. And then this kind of test will not work. You have to do another kind of test. So, but in a sense, it's the same thing. The abstract syntax tree that you describe within your source file, it doesn't change. So although the result changes depending on the environment, the abstract syntax tree doesn't change. So the code base is just has a record of the abstract syntax tree, and how it's applied is a different way. Does it answer your question? Okay. Other questions? Yeah?
So what if you actually do want to test the things with the database? Like you said, you can do this if you need like an I/O ability, and we all know that you can still make mistakes in this kind of code, even if it's purely functional. So can you still use these test facilities for that, or is there something else?
So specifically, these test facilities start with a test watch expression, and that precludes the use of I/O. But the fundamental instinct of Unison is that everything should be expressible in Unison. So if you want to write a test that maybe test the actual deployment of your app in a staging environment, you can write a Unison term that basically expresses what you want to do and what you expect of the result. And then you can run that piece of code that is a test that will express. And there are also I/O tests that have the ability to do I/O, but I'm not going to go into that now. Does that make sense? Other questions? Cool. What I was saying that, because I just met Leo, but now we're friends, so when I see him again, I can say, hello, old friend. And we've created a example 3 test. And we already just added a example 3 test with the same name. So if we now save this file, what we see is that Unison doesn't ask us to add it, but to update it. And there's a small difference what happens underwater, that if, let's say, we try to add that definition, it says it failed because it needs an update. So if you have a codebase manager that sees changes in what is committed and what already is present, it has you can do semantic updating of these definitions. Does that make sense? Nice. So let's go back to some form of presentation. So to recap what I've just said and what we've just done is Unison. So there's a question. So the question is, what is the level, like how much of the syntax is carried over in the abstract syntax tree? So the codebase manager will compile, in a sense, your representation to an abstract syntax tree, and you can do a round trip where you can ask the codebase manager to show the definition or edit the definition, and sometimes it's different than what you expect. Sometimes parameters are gone, sometimes they are added, sometimes, for example, import statements are added to simplify the things. So in a sense, it's also a pretty printer, because it doesn't really matter. And there are also some wild ideas that say, if you're familiar with a Lisp, maybe you want to express Unison in Lisp, and then compile down to an abstract syntax tree and go back that. That's not implemented yet, but it's on the road. That's not on the roadmap. I'm not going to, even if I say it, I'm not with the team, so I can say anything. So there are thoughts of like having a syntax that's familiar to you to express your Unison abstract syntax tree. So I'm not sure about the details, but it's not verbatim, so there's an implementation stack. Does that answer your question? Okay. There's also a question in the back.
And how does this manager interact with my revision control system? So if I do a git pull, then do I have to do like a blind update, or does the git pull include enough information to tell that everything's okay?
Yeah, so that's a very good question. There is no git. So Unison has rethought the process of software development. So they build a repository of projects that you can interact with. So instead of doing Git, you're asking the codebase manager, I want to pull this project into my local Unison codebase, and then I can work on that. And this might sound as a walled garden, and maybe it is. There's a history of, Unison is fairly old in the sense that it has a long, I'm not sure, maybe it's 7 years old, I guess. So they transitioned from using Git as a means of communicating to this more model when they can control how these files should be distributed. So there is no Git, but there is something like Git pull, and there are contributions that you can do, and you can interact with this very similar way of Git. But you have to let go of the idea that Git is the way to do version control of your project. Does that answer your question?
Yes, thank you.
There's still a question in the middle of the row and here in the front.
I'm running.
I'm not in a hurry.
then we need 2 microphones at least.
This is a less technical question, but what happens if, say, I join a company writing Unison code and I pull and push into my code manager, and then I work on some freelance work at the same time, and I push and pull code into my Unison code manager, and then I quit my job, and the company says, "Oh, well, like, don't take any of our code with you, please." Does it yet have features to isolate and purge code from different sources? Thinking also about things like the recent cease and desist that came out against the OpenTofu project, which they had to basically trace and argue that this code could not have come from original Terraform, things like that.
A good question. So the caveat still holds. I'm not sure, but currently there's Unison Cloud, and that's a single platform where all projects can be shared. I do think that the Unison computing team is envisioning a future wherein these choices for companies that are don't want to share their code with others can land. But I'm not sure what the current situation is. But they all have an answer.
So this is a kind of a follow-up to the Git question. So you showed us that things that are named can be referred to as name, but once you actually compile things, they become references to that specific version or that specific implementation of that name. So my question is, like, what about inner nodes? And what I mean by that is that, like, ages ago I used to work somewhere where we were doing similar things, and one of our crowning achievements was that if 2 people were working on the same program and one of them factored out the middle of a function, so something that was not named, something that was just a middle of something, one person factored it out into a function and the other person edited the code. This was not a merge conflict because all nodes had strong identity. Does Unison have an answer to this problem?
Yes, and I have a demonstration of that. So basically, I may overspoke, but there's also meta information about the abstract syntax trees, such as a name. So if you want to give a name to something, that's allowed. You can even give multiple names to the same abstract syntax tree. The other thing is that because the codebase manager has all the definitions and the references as that, it will detect if you change a definition it will notice, hey, this definition changed, it's incompatible with the place where it was, so you have to update these places as well. So it's not such a merge conflict, but it will detect that you need to do something. And sometimes it can do the things automatically, but more often not, it can be done automatically, and then the developer needs to have a choice. These things change, I have to update this in this way, and that's the demonstration I will give you in a short time. Does that make sense?
I'm not sure it's the same thing, but I wait for the demo.
Okay.
Thanks.
Other questions? Not for the moment. Okay, so to recap, Unison does make use of files, but they aren't a central concept. The central concept is the abstract syntax tree. And it is stored in a database, an SQL database, SQLite database, and it has a hash that references to that abstract syntax tree with a lot of metadata, such as names and such as other things. So what does this offer you as a developer? Like compiling in the sense of the image by XKCD isn't a thing anymore. Because if you add it to the codebase manager, it's already compiled, and then you can share that in that form. So there's no update of the entire project because a single file changed, because Unison has a notion of what the abstract syntax tree refers to, and if it needs to recompile, or if it's in the codebase, it's already compiled. So no more I'm compiling, which may be a shame, but that's one thing. And if you have a representation of an abstract syntax tree and you have a means to serialize that, then it's also easy to share your information. So instead of having to think about serializing a value, sending it over the wire, you can just send the Unison abstract syntax tree over the wire, and then it's allowed to do. So this paves the way for distributed computing, because let's say you want to parallelize a computation, and you want to say, I want to do this kind of work on that node, and I want to do this kind of work on that node, and those nodes run Unison, and you ask it to do a computation. It can look in its code base and see, I am missing this abstract syntax tree because I don't have an entry under this hash. But what it can then do is it can ask the originator of the computation for that definition. That definition can be sent over the wire, and then the new codebase manager has the abstract syntax tree, can do the computation and work. So this mechanism of entering this codebase, the abstract syntax trees, allows you to do a lot of things more easily than before. So demo time again, and let's see if I can fulfill the promise of showing what works. I did forget to show one thing, so let me clean this up a little bit. Because what I showed you in the terminal, you can also show that in the UI. So this is the local instance of the Codebase Manager, and it shows your project. And what you can do is, so let's look at the code we already seen. You can browse through some of the terms. So here's the term for greeting for, the term that's responsible for generating a text to the user, and there's this documentation. And notice that this documentation has evaluated the specific instance of this abstract syntax tree into the code base. And if you look at the doc term for that scene, just says it's a code block that says greeting for Lambda days for one times will result in what you see in the definition. So in a sense, these docs are living documentations that can show how the function behaves by examples, by actually doing the computation. And in that sense, if you change greeting for, these references need to be updated as well. What I wanted to show is another demo, and you have to imagine a little robot that is roaming around on Mars and that we are writing software for. So just to quickly view the different types that are responsible, there's a compass type, which is nothing more than the compass directions. I think I can, yes. Is this readable-ish? Sure, okay. There is a location, which is a Cartesian product of the X and Y orientation of the robot. And then there's a robot itself. And a robot has a compass and a location. And what we want to do is there are some of these functions that are on location. For example, towards, that returns, if you give it a location and a compass direction, the location that's towards that direction. So let's explore that. And let's edit it as well. Because so what we see here is that the towards function has a bit of a defect. It does work. We can show that it works. So let's have a watch expression. And we have to give it a location, for example, the origin, and a complex direction, for example, north. And what we see below in the screen on the left side is that if we go north from the origin, we are at Cartesian location 0, 1. So the first argument is the x-coordinate, and the second is the y-coordinate, and I'm using mathematical notation. So It's on the bottom left. But the problem is, if I want to go towards north twice, I have to basically save this result and then feed that result into the next iteration. To see that we have a step. So what I rather would write is that the pipe style, that if I have a location and I go towards north, then that the arguments. So basically what I want is I want to change the argument order. So let's do that. So I'm writing, rather would have the compass before the location, and then the third compass isn't necessary anymore. Oh. Wow. And then the direction must come first. And nothing else really changes. So we can save this. And now something happens. It should happen. We can update these things, and if we try to do that, it works. And so what I just did, I tried to update, and Unison checked if this is possible. And because that the order of the words changed, and the words has dependents, we have to update those locations as well. So what we can do now is reloading the file, and then Unison has wrote to the file that I'm working in all the things I need to update, basically. So I'm notified of the problems. So let's see. I think this is okay. The documentation is also correct, but here in the execute method of the robot, we need to change the order of the compass. So we begin with. Oh. That's a good question. So the question is, can I do that automatically? Yes and no. So there's a means in Unison to do term rewriting. So if you know, and we know very clearly what the actual code should look like, so we can write a Unison term that basically sees what should be changed and do the manipulation. But I'm not going to show it here. But it can do that. But you have to do some other things. Does that make sense? Yes. Thank you. So let me think again. When I do a move, the compass does the same, but the towards needs to be changed because the order of compass and location is changed. And I think that we can now update. And it's done. So to reiterate, I noticed that I created a term that wasn't ergonomic. I couldn't chain this method, so I changed the argument or order. I tried to update the Unison Codebase Manager, but it told me that I couldn't because there were dependents that needed to be changed in order to apply this code base in a safe way. So it loaded them up in my editor. I could peruse them, change the definition that were needed, and then I could add them. Does that make sense? Cool. So let me switch browser. So where to go from here? So this was, in a sense, a small nibble of what Unison can do. I even haven't talked about the language itself, what it's capability of. And one of the more interesting things that Unison can do is that it has effect handlers. Tomorrow there's a keynote that goes into effect handlers, so I opted not to show them in Unison. But if you're interested, come by. I would love to show you because it's really an interesting feature and a different way of looking at computations that is very variable. Everybody was aware of Unison, but not everybody had experience coding it. And what I would invite you to do is go towards the Unison language website and just start exploring. One of the ways you can explore is you can visit the community. There's a Discord which allows you to ask questions. It's a very friendly community. The core developers are very open and eager to share their knowledge and even invite you to pair program with them. It's very lovely. The community, or the language, in a sense, is still in its infancy. They did start Unison Cloud, which is the platform that you deploy services to. It is full-featured. There's a database that you can use. You can do HTTP requests, and it's maturing. But you might feel that the libraries that are available to you are still lacking. And this is an opportunity to contribute. So if you're interested in looking, you can also contribute various libraries. Are there any questions?
Thank you so much. And I can tell already there are a lot of questions, so I'm going to make a round.
Thanks for a great intro to Unison. I have 2 questions, actually. So the first one is that if the AST nodes are hashed and all of that is kept in a global repository, then the assumption is that they are pretty stable, because if we change the shape of an AST node, well, we would run into a cataclysm, probably almost as bad as the removal of leftpad from NPM. So do you think there are any procedures or ways to prevent a situation like this?
This is a good question. So if you share your code on the Unison code base, it's there forever, in a sense, I guess. Probably you can remove it in a sense. But what then happens if you... so let us say this. If you want to use a library, what you do is you pull that library into your own local code base. So then you have a copy of the abstract syntax tree. So even if the publisher of the library decides that it doesn't want to share the library anymore and wants to evict it from the share, you still have a local copy. Legal questions, I'm not sure about how those are going to be resolved, but at least you have a local copy, and that can be changed as easily. So I think that the problem with the left pad was that it was still there as a library, but the definition changed, and because you are in control which libraries you pull down and what version you're going to use, you're aware of what's happening, at least.
Mm-hmm. Yeah, well, the part about leftpad was more of a joke. I mean that if the authors of Unison wanted to, let's say, evolve the language, evolve the representation of the AST, then it actually is a global problem for Unison Cloud.
Sure. So one of the things that happened is that there was an update. The recent update of Unison, they changed the format of the abstract syntax tree in the database. But because it was written in Unison, they could migrate your current projects into the new form. So it was a seamless integration. So yes, changes to the language are very maybe scary, but the team is very responsible and thinks ahead of time what they want to do and how to adopt that. So there are, for example, the record syntax in Unison isn't very expressive, and they have a migration path towards more extensible records, for example. So yes, it is an issue, but I think that the Unison team is responsible and safeguarding that for those catastrophic events.
Mm-hmm. I get it. Okay, thanks. So it's great because it's not only foreseen, it has already happened and went well. So
yes,
great. And the other question is that, well, the AST is, let's say, an earlier representation of the code. Their code generation has to happen somewhere. So it's not exactly true that there is no compilation step anymore. So where does it really happen? On the local machine? Because, well, it has to be compiled to either for a VM or for our specific architecture.
Sure. There is a representation of the abstract tree that's on your local machine. And there's also in the works, and they're testing with it, a just-in-time compiler that will compile it to native. So you can run native code after a compilation step. I'm not sure of the specifics, but we should ask the team about that.
Okay, thank you.
Thank you.
Different programming languages tend to be optimized for different goals. Can you say something about what Unison is optimized for?
Yeah, so Unison claims to make programming fun again, so that's one thing, and that's really important. But they really want to bridge the gap from a single machine to a cluster of nodes. So computer language nowadays are really expressive about single machine instructions, but once you have a distributed cluster that you need to coordinate, it's basically glue that you have to tend together. So I think that one of the key tenets is that if everything is a term, you can express computation in that sense, but you can also have a type-safe database that is abstracted in terms of Unison terms instead of low-level bytes, in a sense. So maybe in one sentence, make everything accessible within Unison. Does that make sense?
Yeah. It's a little different than what I was looking for.
Okay.
But it's what it's optimized.
In my words, at least, and I'm not a part of Unison. But let's talk about in a later time.
I think we might have time for one last question.
I think what I want to ask is almost the same question as the previous one, which is that why does Unison need to be a language? Like everything you showed us is about like managing code and managing dependencies, deployment, and so on. But that does I don't think we've seen anything that really wouldn't work in any like off-the-shelf functional or pure functional programming language. So. And of course, there is a cost to siloing or balkanization, if you want to be negative about it. So why does Unison need to be a language instead of just something that you use with other languages?
Yeah. So what I didn't show was the distributed stuff, and I think that one thing that Unison makes possible is to easily express distributed computations within Unison itself. And the other part is, it's like the lens talk that was earlier this day. The main premise was, I have this domain model and I want to express that maybe to the database, and I want to express it to a service and to other things, and I have to write, if I don't use lenses, these transformations from the actual domain to the representation that I wanted them to have in. And if everything is Unison and all those transformations are done for free, a lot of those boilerplate that you need to write go away.
But I guess the question is like, isn't that just providing tooling for a language, and that language could be an existing language just as well as it is a newly thought up one?
It might be, yes. But there's also the benefit of having the abstract syntax tree as a means of computation instead of the files, I guess.
Yeah, and then every programming language has an AST.
Sure. Let's discuss offline, or at least if there's no more questions.
Thank you. I think there are no more questions. So thank you very much for presenting and for attending.